from Indigo R of Alt Tech Hub and Foundation. This is the first time we have this innovation of, well, two of us chatting and having you see us full screen without pictures or without those questions coming up, called the countdown question. The effort has been consistent to try and see how we make ourselves useful to you all, primarily young engineers, business graduates, architects who want to try and see what you can make of a world that is ahead of you in the next 15 years. Typically, from our understanding of what we've been seeing as profiles of people who are participating, we see that you are between 25 and 35. That is two-thirds of the Indian. And the hope is that people like Padma Padmanabhan, who sits here today with me to spend these 60 minutes to offer insights from a very discerning and shall we say, very, very unique and distinguished past that he has had in a way that you pick learnings. And so I remind you again, on the left of the screen, you see the chat box. Please put in as many questions as you can. You can be rude. You can tell Mr. Padmanabhan, sorry, we didn't understand you. Can you go over that again? Let's try and see if we can help you. We'll see if we can offer it either offline or at the end of the session that we will be doing with him. We keep it informal. We're keeping it with questions that I will ask of him and see what he will want to offer. Let me begin by asking Fadu, who's been a dear friend, by the way, of the work that he's currently doing with the GCC countries. He's just come back from Riyadh in Saudi Arabia, and he's also been working in China to try and see what he can give them as a larger picture of energy strategies that they will want to emerge with over the next decade. On the China program or the proposal that we're talking about, you said something interesting. You said that China has begun to see that what you're offering them makes sense. Where did it begin, and what is it that you're offering?
First of all, let me step back and say that this is a team effort, and I am working with the King Abdullah Petroleum Studies Research Center in Riyadh, and as part of a collaborative effort between CAPSAC in Riyadh in Saudi Arabia and the Energy Research Institute in China, there is a program to advance industrial energy productivity. More to learn from the Chinese experience and transfer it to Saudi Arabia and other countries. Having said that, there are also opportunities to examine whether one could advance the China effort a little further. And what we are doing very briefly is to understand how China has been able to implement very successfully energy efficiency in the industrial sector and achieve targets which have been achieved over the last several years in amounts which are truly staggering. China is the only country in the world which has reduced its energy intensity in the value-added sector by 5% every year upon year since the last 10 to 15 years. They are probably the country which has the largest energy efficiency market. I don't remember the numbers right off the bat, but their energy efficiency market runs into billions of dollars, involving more than 150,000 employees, involving more than 8,000 companies. All of this has happened due to certain measures taken by the Chinese government, both prescribing and following up on certain energy conservation targets for energy sector industry. Very broadly, they have a strategy which requires very inefficient industries to be closed down, other industries which can improve to certain targets, and future industries to meet some futuristic targets. And based on this three-pronged approach, they have been able to establish energy efficiency as an important strategy to their energy.
And you said there are 4 quadrants to such.
There are 4 quadrants, and very briefly, the first quadrant is what I would call as the quick hits or the must-do, or the quick hits or the housekeeping measures, which are low cost, no cost measures, which an industry could very quickly and easily employ. And indeed, Indian industry, particularly the large organized sector of Indian industry, have employed several of these measures, although the SME sector needs to do a lot more. The second quadrant is where a certain level of investment is required to generate the savings, but the return on the investments are pretty attractive, less than 2 to 3 years. These involve insulation, waste heat recovery, and things of that kind. And Indian industry has been engaging itself in reaping some of the benefits of the second quadrant. The third quadrant is where Indian industry is moving towards, and this is where you have transformative technologies, you have restructuring of the sector, you have different processes which need to be inculcated and introduced, such as in cement industry, where you move from wet process to dry process, or in paper manufacture, we go in for continuous digesters as against intermittent digesters, and so on and so forth. These could give you dramatic savings. And the fourth quadrant is where one could get enormous savings through a systems approach as against an individual approach, such as the circular economy and so on. So, digital manufacturing.
How does the circular economy connect with systems?
Well, the circular economy is essentially integration of various systems to deliver an efficient product or efficient service by ensuring that the output of one particular industry becomes an input to another, and therefore there's synergism between various manufacturing processes.
I pause here to suggest you all to understand as much as you can about circular economy, because the next 5 years this is going to be the phrase. If you're an engineer, to anybody who is managing things in organizations. You also said that there are indicators and they again cascade into programs.
Yes, if broadly speaking, I would like to use the term energy productivity over energy efficiency, and I'll explain to you a little later why. There are four specific indicators for energy productivity. One is at the macro level of every nation, and that is the GDP per unit of energy consumed. And the GDP is essentially could be on purchasing power parity on the PPP basis, and it is an indicator as to how efficiently energy is being consumed to generate how efficiently it is consumed to generate a unit of value addition. And every country it can be ranked against one another based on the GDP for energy consumption. Although it is not fair to compare one country with another using that number, because it is a function of the structure of the economy. So if a country has, for instance, a high level of service sector, the energy consumed per unit GDP is substantially less than a country which has heavy industry or energy intensive industry, where energy consumption is much higher per unit of value added.
Productivity comes in places where there is high activity, high energy use, and efficiency comes in places even if there isn't that kind of activity, right?
Well, that's part of the.
I'm trying to simplify.
That's part of the answer, but when you look at productivity, you look at unit of energy which is used to generate a unit of value added as against an output. Let me give an example which will make it clearer. You have an industry which generates, let us say, which manufactures paper, and you have an energy efficiency approach. You look at energy efficiency of the boilers, energy efficiency of the steam system, and try to reduce the energy input for every output of energy that you produce. You have a productivity approach, you do it a little differently. You definitely improve efficiency of the equipments and boilers and so on, but the steam that is generated would be used to produce paper, and you can use that steam to produce two types of paper. One is the ordinary paper which doesn't fetch you much money in the market, or specialty paper which produces more money in the market. So value addition by manufacture of specialty paper is greater per unit of energy than value addition per unit of thing. So the idea and the purpose is to go in for high level manufacture so that you, or high value manufacture, so that you move from traditional industry and basic industry to more value added. You move from aluminum to aerospace, for instance.
Let's take a very random one, keeping in mind what alumina, bauxite to alumina to alumina. Today runs at, I'm right, correct me if I'm wrong, 3 tons to of ore to as little as about 0.3 weight as finished product. Is this something the industry can do? On much the same lines you are talking about when it comes to paper manufacturing. In order to see two things that happen. One is that the quantum of natural resource that you're mining is reduced. That is the ecological productivity, more than simply the economic productivity process.
Assuredly, I think that's
That's
certainly
part of the
possible, and
agenda.
that companies and energy efficiency strategy.
Are you seeing that as part of the agenda for industrial energy?
Absolutely, that is part of the agenda. Now, coming to aluminium, for instance, and looking at it from a energy perspective as against the materials perspective, it requires in a smelting operation about 15,000 kilowatt hours per ton of aluminum to be produced. Best available technologies can bring it down to 12,000 or 11,000 kilowatt hours per ton. Now the question is, how do we move industry from the current practices to adopting the best available technology practices? So there are ways and methods of doing it. But the earlier point that I made, the aluminum is then used in subsequent processes, and whether one can have more of high value addition processes such as I mentioned, aerospace, so that the value addition to aerospace per unit of energy used to produce the aluminum is much higher than if it is just used to produce the aluminum in the first place.
Look at this man. It's amazing how he can straddle industry and talk yet about technologies at current levels of weatherization and home approaches where necessary at the retail. And the reason I'm saying this is, in a way, I want to take you back, by the way, to that time in the early 70s, in 1972 or 73, when you did your first dissertation on industrial efficiency and energy. If I remember right, you've been saying how it was not even called energy at that point. It's called fuel and fuel efficiency. Can you go back to that time, transport yourself to that decade, and tell us of what those experiences were like and what you moved?
Well, I was in an era which coincided with the oil price hike of 1973, where, as we all know, that oil prices increased because OPEC was formed and the oil producing countries formed a cartel and raised international oil prices. To India, it was a major dent because almost one third of India's foreign exchange earnings were used to import oil, and an increase in prices would have made it extremely difficult for the economy to bear. So at that point in time, the government of India felt that there was a need to improve the efficiency of fuel utilization. So there was a fuel efficiency service with the National Productivity Council, which I happened to join. But prior to that, we were trained in the subject of fuel efficiency. And the subject of fuel efficiency later became an important part of the government strategy.
About that one case study you did in 1975, where a company suddenly woke up and said, from what it was, it 40,000 rupees to a ton, or was it 40 rupees to?
Well,
to what those costs are today.
Yeah. In 73, 74, oil prices to industry, because furnace oil is used in the industry, and also coal, but the emphasis was on oil conservation, was about 40 rupees per ton. And it increased to something like 200 rupees per ton and many industries were definitely affected. The bottom line was affected, and they complained to the government that they were efficient and they should not be penalized.
And to today's professional, in terms of cost, what would it be now, so that they get a perspective of what
Today it's about 18,000 rupees per ton. So prices have gone up many times since then. But in order to distinguish between companies which were efficient and which were inefficient, the government had a major survey done in various facilities and to advise them on how to reduce the use of oil. And we found that in those days, the wastage was enormous because there were no measures taken to even reduce leakages in either the combustion system or in the steam system. And we were able to reduce these leakages through good housekeeping measures. And one could save 30 to 40% just through good housekeeping measures. I recall the first industry where I worked in was a tire industry in Bangalore, which was using oil very inefficiently, and we were able to save almost 1 crore rupees per annum, even in those days, on account of efficient
operation. What would you have done as a key lever?
Well, the key lever was improving the efficiency of the boilers. You know, the boilers were what were known as shell tube boilers, which were very different from the packaged efficient boilers which are here today. And those boilers are not more than 60 or 65%.
And if you say the saving was wonderful, what was the thing at that point?
I think the bill, if I recall, for this continuous process plant was about 3.5 crores. So that was a lot of money even in those days. That was a very large tire producing company, which today, even by today's standards, is pretty high actually. But today, the same company, if it were to operate, its bill would have been anywhere between 50 to 80 crores for the same volume of manufacturing.
Can you see that? You know, in the context that you have today, and I've got Naren with me from AEEE, the senior researcher there. You heard him a couple of weeks ago, was it 3 weeks ago, talking about how he has been coming up with perspectives on transforming the energy scenario in India 2030. And you must remember that in the next 15, 20 years, regardless of the kind of costs and the rupees and amounts that Paddy was talking about, we're going to have similar situations that you have to be confronted. These are challenges you cannot run away from. I would like to think that these are exciting challenges that you as professionals need to be looking at and taking on. Naren, would you want to say something as you listen to Paddy talk about those times? And you know, the content is not changed in terms of what we need to be looking at. Amounts might have. What would you think?
What people perhaps ask Paddy is, for the last 5 to 10 years, the international community has stood up, and then India has been working with them, including the likes of World Bank supporting us. What has motivated some of the organizations as important as World Bank to work with a country like India? And where is that engagement going, and what does it mean to the economy and the overall energy scenario? That would be a good question to ask, Paddy.
Yes, certainly. What motivates multilaterals like the World Bank or the Asian Development Bank and bilaterals like the USAID and others to work in the energy sector, and particularly in advanced energy efficiency? I think that's an excellent question because these institutions have recognized the importance of energy efficiency in the economy of these countries. The reason is quite simple. If one were to look at the power sector in India, one would realize that a certain level of subsidy is being made available to shore up the losses on account of the subsidy, shore up the losses in agriculture. Very simply stated, the extent to which the losses faced by the sector are showed up is to the tune of 40 to 50,000 crores per year, and that is because the agricultural sector pays a tariff far below the cost of supply. And in order to ensure that the utilities are not faced with losses, the utilities are provided a direct subsidy by the government, by the state government, and also an indirect subsidy by way of cost subsidy, where the utilities can get more money from the high-paying industrial sector.
That's an old challenge we have had.
It's an old it's an old challenge. It's an old challenge, and that challenge has been addressed somewhat by different strategies now. But the point I would like to make is to address the question that Naren asked: why are the bank and others interested? Is the fact that to the extent that the direct subsidy is met by cutting down your investments in the social sector, such as health and education. To that extent, the social sector's their development suffers. In fact, the losses in the Indian power sector is double of what India spends on health and half of what it spends on education. And to the extent that one can reduce the losses, to that extent one can reduce the direct subsidy, one can reduce the fiscal deficit. And much of that is directly related to technical approaches to reduce losses as well as other management approaches.
Stakes is to, when you talk about losses, the most obvious thing that we talk about is somebody is generating at some central level, and therefore we run into this Himalayan sets of obstacles that come before us on losses at various levels. And then, of course, the inefficiencies of administration of the whole system itself. If I recall, we were reflecting upon how these efficiency strategies that India has taken now, has sort of wrestled with in the last 25 years, have to do with two sets of stakeholders. The easiest set of stakeholders are the government and people who actually put together a thermal plant or a nuclear plant or some such thing, and some huge, lots of money is spent on making such a central infrastructure for generation. The other is to see that we go about the sort of things that we're talking about and have always been speaking about, which is to do with how I involve everyone, engage everyone in bringing about those things. Then every unit that you say is a unit generator, as that actually that you have also been often talking about. I mean, do you want to say something about it before we ask him to respond to that?
You answered the question. It'll also be good if you tell us how bad or good India really is. Right? We know, for example, the cement sector is one of the top three most energy efficient across the world. But we probably know agriculture sector is bleeding. So while you address this, you could also touch upon where India could possibly stand. I don't know if there are global reports that say that, but where could India possibly stand?
That's more at the consumption things, even if it's industrial. But I think I wanted to look at this larger architecture of central, what I'm saying, of infrastructure there, and then the stakeholders on the other side. And remember, this session is about how energy efficiency is everybody's business. And that's one of the reasons I'm asking this question. And I've heard Padma Padmanabhan talk about this in the past. So I thought this is part of the conversation. Questions, please. As many of them as you can put up there for him to respond to at the end of the session.
I'll answer both the questions, but first I will address the question that Hari asked. The energy equation has two sides. There's the supply side and the demand side. And one needs to work on both sides of the equation. In India, we have largely worked on the supply side of the equation. And we have made progress.
Because it was easier to work upon?
Because it was easier, decision making was in place, and we have made progress. From a base of 1,000 megawatts in 1950, we are something like 300,000 megawatts today. So clearly we have added capacities and we continue adding capacities.
It wasn't the right thing to do.
That possibly was not the right thing to do given 2020 vision. But today there are alternatives. In those days the alternatives were few, and we focused our attention on the supply side of the equation. And
why was it easy to create such?
It was easy because the decision-making process was highly centralized. It did not require widespread consultation. It basically required the utility, the government, who was also the regulator in those days, as well as manufacturers of equipment and a financial institution to come together and take the decision and put up a power plant. And of course, there was the linkages with coal or oil or whatever the case may be. But those were technical decisions which were resolved, and the decision-making process enabled one to do that. To set up a 1,000 megawatt power plant from that perspective was quite simple. But to save 1,000 megawatts from the grid, which means that you work on the demand side of the equation, requires enormous effort because it's the use is highly decentralized. Everyone is involved in consuming energy, and you have to reach out to every sector and every individual in that sector. So that made it a lot more difficult.
Aren't we clearly moving into an era when, therefore, the saving is a lot more important than the supply side generation?
That indeed has been the experience in several countries. In the IEA, when they first began the energy reports in 1980s, they used to call energy efficiency as the fifth fuel. It was far behind oil and coal and renewables and
Here,
so on.
who would be the stakeholders?
Well, the stakeholders are very many. But before I come to the stakeholders, why energy efficiency is now the first fuel is because in 11 out of these 16 IEA countries between 2005 to 2015, more energy has been saved through energy efficiency than has been generated through conventional coal, oil, and hydro, and so on. And that's why it's considered to be the first fuel. It's also now well known among the lending community that energy efficiency has delivered more in terms of savings than renewable energy has produced through the various programs of the renewable energy. So energy efficiency is ahead of renewables, is ahead of. But in spite of all of that, the potential for energy efficiency is large. And I would now like to defer to Naren's question, if I may. In certain value-added sectors, because 45% of the total energy in India is consumed in the industrial sector, which makes it the most important sector as far as efficiency opportunities exist. And in Indian industry, particularly in some of the energy-intensive industries, almost 50% of energy is consumed in four sectors. That is iron and steel, aluminium, cement, pulp and paper, and maybe to some extent textiles. But these are the four sectors. In each of the four sectors, India has had a record which isn't very positive, excepting for cement. In cement, the energy intensity defined as the energy consumed per unit of production, kilocalories per ton of clinker produced or cement produced, India has a value which is probably the least in the world because of technological interventions and good management practices. But in iron and steel, we are much higher than that of the developed countries. We are higher than the global average. In aluminium, we are higher than the developed countries, and we are almost on par with the global average. In heavy, high-value chemicals, particularly petrochemicals, we are again way behind the industrialized countries. But we're catching up there. In ammonia, for instance, we are as good as any of the world.
But another session that Naren did with us with EcoR, he was talking of how India could become the energy capital if I look at the next 10 years. Is that right, Naren? And why I'm saying this now is that do you see such a transformation happening, especially in these four energy sectors?
I do see the transformation happening because
in the way that we lead the world.
We could lead the world. We have done it in the cement sector, and we have done it in some of the other industries, but haven't made it economy-wide, but done it in a few examples, because there are a few companies which are extremely efficient and as good as any in the world, but the bandwidth is rather broad, because in the same sector, you will have some industries who are very efficient, and there are many which are inefficient. And the challenge really is now to improve the efficiency of energy use.
Stopping there. Noted.
While you were just saying that, where do you think technology can be a part of this whole ecosystem? There is IoT that people are talking about, Internet of Things, there are metering devices, smart devices, controlling devices. Now, where does all of this tie up together in the overall energy scenario? Because we understand, I don't know, more people understand technology in India today than maybe energy. So is that a way?
How has China done that in the last, say, decade since you've been, getting a grandstand view there?
Well, technology as defined by you is more of information. So there are two types of technological intervention. One is process technology. What are the best available technology or best technological practices in place in a particular sector, and how does India compare? In all the industries that I talked about just now, India is way behind the best available technology. So there's a lot that can be done there. On IT and information technology, here the opportunities are tremendous. Let's take a unit at a plant level. Energy is used in the production process, and the consumption of energy changes over the day, changes over the production pattern, changes over the load factor of the industry. There are several parameters which affect the consumption of energy. If one can devise a system where energy use is monitored on a continuous basis, made available in a format to top management for them to take decisions, and this should be made in a way in which one relates energy consumption to production, what I would call as an energy information management system, then action can be taken simultaneously to reduce the consumption through various interventions, operational interventions. If every company in the country were to install an energy information management analytical system, IMAS as I call it, the opportunities for energy savings would be large. What does it entail? Clearly, it entails smart meters. Clearly, it entails a computing data acquisition system, data analytical system, development of algorithms, both on the software side and on the hardware side. So that kind of a system is well within the realm of today's Indian IT industry and professionals. But somebody to go in and do the kind of analysis, provide the analytical base for such systems to be established and for platforms to be established is yet to fall in place. But I think it's just a question of time before EMAS system is in place. This is at one level. The second level is equally important, and that is how do we collate the information from the various EMASs which come from the industry to a centralized energy efficiency data repository so that the government can set up targets for that industry. So the targets are very realistic. This is very important because if we take the experience of China, China has been able to improve its energy efficiency 5% year upon year and set up the world's largest energy efficiency business community. Is largely because of the fact that they were able to establish realistic targets and monitor these targets. So this EMAS system at a unit level combined together on a common platform to establish a centralized energy efficiency data repository, enabling governments to set up targets and monitor the targets will be part of the architecture for an efficiency strategy, at least for the industrial community.
How does that tie up in some simple way to have every single stakeholder, producer, government, regulatory, to the consumer of various kinds of products in a way that
Interesting question. Obviously, the system that I talked about is more in keeping with the organized sector of industry. But then there are other subsectors, such as the small and medium scale industry, which may not fall under this. end users, such as in homes, residences, hospitals, etc. How do we motivate them and how do we involve them in the efficiency business? One clearly, and this has been, it's not in hackneyed terms, it's been mentioned several times, is to build awareness. And awareness building is important, it is continual, and recognize that there are more and more people entering into the workforce.
What is therefore the role of those who are entering the workforce or already in the workforce? I'm between 25, 30, 35, let's say, in the system class 5 years, or I'm a fresh graduate entering, a career.
Well, the opportunities are very much more than when we entered our career. In fact, when we entered the fuel efficiency career way back in 73, 74, there were very few business opportunities. So one only worked with programs sponsored by the government. But today, many industries, many have mainstreamed energy efficiency as part of corporate activity. So one could join energy management programs or the energy management cells. Having said this, there's opportunity for startups to establish this EMAS system that I mentioned. So that is one area that they can involve, getting involved in energy analytics. The third is energy service companies, which I think Naren can talk more about.
Or has in his last session at OR.
And then awareness building, etc., is important for education, to develop education material,
Right.
and promoting and propagating efficiency.
I will take you to that other question of how, you made this very memorable observation of India being the tech capital and how it can clearly be the capital. Where do you see that happening and how? Given what he has said about EMAS.
Sure. So if I can analogously tell something, working in the Western world and in the developing world like India, right? At home, we like to give the job to others, right? Versus in the Western world, it's a do-it-yourself attitude at houses. Whether it's plumbing, whether it's furniture, whether it's cleaning, driving, they do it themselves. Versus in India, that goes outside. But having worked with ESCOs here, what I found was you go to an industry and tell them you could do 10 things, they'll tell them, I'll do it myself. Right? Versus in the Western world, they just stick to their core competency. I'm not an energy expert. I am an expert of producing cement. I'm an expert of running my hotel operations. Let me bring in an expert who can do this for me. Right? Because there is cheap labor available.
You're saying there's a higher level of engagement.
Right, because people are available, right? I don't necessarily have to stick to my core competence. I'll hire those energy auditors and put inside, and then do it. But what's happening is because of that, where I can probably save X amount of energy, today I'm able to save probably 60 to 70% of those energy, and I feel happy that I've saved 60% of that without even realizing that I'm losing that 30, 40%. And that is where technology can come in and then clearly say to benchmark against peers, benchmark against the country-wide system, state-level system, similar production, similar technologies, etc., and then say no, you are not 100% yet there. You are only 70% there.
It goes back to measure, monitor,
Exactly, right? And that is where I feel technology could be a savior, and information technology, as Madhu rightly pointed out, and probably why not build up those systems through IoT, through sensors, through smart metering systems, and bring in that awareness. And once you have that awareness, step two is probably much easier.
I think Pablo has also said in many ways today that as China has done, and the lessons clearly here for us in India, the investment on energy efficiency options and avenues is going to be rising significantly in India as it did in China. And that will take us back to technology and therefore all the measures and data monitor and stuff.
But there's one major element of what we are talking about, which needs to be harnessed, and that is the power of finance. Uh, Availability of finance, both the institutional finance as well as finance, the capital markets needs to be harnessed to invest in these projects. ESCOs definitely bring in some of that, but there are financial institutions, both domestic as well as international, which may have lines of credit for energy efficiency and make it attractive for end users to utilize those lines of credit. So that is an important aspect of whatever we are talking about, because many end users do not have the resources to invest in efficiency, especially when you go on the short-term measures,
I have
the
a,
medium and long term.
I have a very quick question and maybe 30, 40 seconds for us to wrap this up. We are at 300,000 megawatts, as you said. Do you see ourselves at the central generation level going up to 700,000 megawatts as the previous government said in 2013 or 12 or so? Or do you see us continuing this grid generation and increasing the prosumer kind of phenomenon?
I'll answer your question a little bit, but it will come to the same amount in terms of megawatts. Today, India has a per capita consumption of about 900 kilowatt hours per person. The United States has something like 12,000 kilowatt hours per person. And the world average is around 2,500 kilowatt hours. Now, for India to reach the level of the developed countries like the US or Western Europe of 10, 15,000 kilowatt hours per person would be virtually impossible. Even 300,000 megawatts,
already
we'll need a fourth planet, and that's virtually impossible and is neither desirable. But India can be at 2,000, 2,200 kilowatt hours, twice the amount, no more, and have the standard of living of the Western world, and probably even better standard of living at 2,000 kilowatt hours per person through efficiency. So yes, there would be an increase in our generation, but the increase in generation need not be through fossil fuels, it could be through renewables, so that the impact on the environment is reduced and the balance can be met through efficiency. So efficiency is the bridge by which we move into a renewable dominated world, from a coal and oil dominated economy to a renewable dominated economy. Efficiency can be the bridge, and it will not only be a bridge, but it will also be a base loaded power plant which will generate power continuously 24/7.
I think that's a nice way of closing this. Naren, I know you've always been a silent observer, but those two interventions or things that you brought in as perspective helped. I guess we need to close this. We are already 45, 50 minutes on this session. There are questions that have come in, and you can be sure that Padu will answer those questions or respond to those perspectives and insights that shared. Thank you so much for being with us.